All right. Hello, everyone. Today we are looking at two new gas laws, Gay-Lussac and combined gas law. Okay, so first we'll review pressure. Make sure you know your different units of pressure. So atmospheres is the most common here, but we might also see kilopascals, millimeters of mercury, torr, and pounds per square inch. So Gay-Lussac's law states that pressure and temperature are directly proportional. So if you double the temperature, you also double the pressure. Okay? If you decrease the temperature, you also decrease pressure by the same amount. Let's get right to the practice problems, or the example problems rather. A gas exerts a pressure of 1.5 atmospheres at 27 Celsius. The temperature increases to 127 Celsius. What is the new pressure? So first thing we want to do is convert these to Kelvin. So remember, we want to add 273. This becomes 300 Kelvin, and this becomes 400 Kelvin. And then I always like to list out what's given in my problem. So I start off with a pressure of 1.5 atmospheres. I have a temperature of 300 Kelvin, and I'm trying to solve for the new pressure while I have a new temperature. Sorry, that should be a T. A new temperature of 400 Kelvin. Now that I've got everything in the units I want, I can go ahead and plug it into my equation, which you see here. So 1.5 over 300 equals P2. We don't know P2 over 400 Kelvin. To solve here, we just multiply both sides by 400 Kelvin. These cancel out, and we're left with 400 times 1.5 divided by 300. And we get, oops, sorry, that should be, 200. Oops, sorry. Just 2 atmospheres. And that is the answer. So here we see the temperature increase slightly from 300 to 400 Kelvin, and therefore the pressure also slightly increases. Okay, another Gay-Lussac example problem. A gas exerts a pressure of 2 atmospheres at 11 Celsius. The pressure decreases to 1 atmosphere. What is the new pressure? So here the pressure is being halved. So first, again, you want to add 273 to this number to get 284 Kelvin. And we can just start labeling what we're given. We started with 2 atmospheres, and that became 1 atmosphere, so it was halved. Our temperature, we start at 284 Kelvin. So I would expect the temperature to get halved as well, because they're directly proportional. So let's just check the math here. We'll plug it in and see if that's actually true. Okay, here I want to cross multiply, so I can rearrange this. T2 times 2 atmospheres equal to 284 Kelvin times 1 atmosphere. Divide both sides by 2 atmospheres. And we do indeed get half of the temperature of 142 Kelvin as our final answer. Okay, I know I went pretty quickly through that, so feel free to rewind the video and rewatch it. Hopefully you understand it better by rewatching it. Okay, so we learned a bunch of gas laws. If there's only a way we could combine all of them into one gas law, and fortunately there is. If you remember one gas law, just remember the combined gas law. You can just use this one, and if they don't give you a certain variable, you simply do not include it. But sometimes you'll have to use pressure, volume, and temperature to solve, and that's what the combined gas law uses. You're going to need to know what STP is. This is something we talked about before, and that stands for standard temperature and pressure. So the standard temperature is going to be 0 Celsius or 273 Kelvin, while the standard pressure is 1 atmosphere. Okay, so we're going to use that to solve the next problem. Okay, the last example I want to go through uses the combined gas law. So it says a sample of gas exerts 2 atmospheres of pressure, takes up 5 liters of space, so liters is volume, and at a temperature of 27 Celsius. So a lot of information to write down. So let's start. And I'm also given a temperature. What is the new volume? So I don't know what V2 is. When the pressure and temperature are changed to STP. So standard temperature is going to be 0 Celsius, which of course is 273 Kelvin. And then standard pressure is simply 1 atmosphere. I want to convert any Celsius to Kelvin, so 27 plus 273 becomes 300 Kelvin. Now I can plug it into my equation here, now that I've got all my variables. So this should be a 2. Okay, so P1, 2 ATM, times V1, 5 liters, over T1, which is 300 Kelvin. That's going to be set equal to 1 ATM times V2 over 273. Luckily, the math is pretty easy here. We just have to multiply both sides by 273 Kelvin. Sorry. So that'll cancel these out, and the 1 atmospheres will just be canceled out. And then we can solve for V2, which is 273 times 2 times 5 divided by 300 Kelvin. And we get a new volume of 9.1 liters. Okay, and that's how you solve these combined gas law problems. Just a little more numbers involved, but the idea is the same. We list out what we're given, we convert to Kelvin, and then we plug it into the equation. All right, if you have any questions, make sure you drop by student support or ask me during class.